So, good evening, everyone. Thanks for joining. We'll start in another 5 minutes. Good evening, everyone. A very warm welcome to our first online meetup under the series of Build with Python on Azure. Uh, I'm Shubham, currently working as a program manager at Skillensa, and we have planned a series of 4 online meetups which will help you to upskill your knowledge on Python on Azure. So, like for today's session, we have Ronak Banka, who works as a senior solution architect at VMware at Tanzu. Like before we get started with our speaker session, I'd just like to tell a bit about Skillenza and what do we do and today's flow also. So we are basically a challenge learning and a peer learning platform. We use challenge model to help companies and to discover the relevant talent and hire better people. So these are some rewards which you get when you come to our platform and when you run any of our activities. So the flow for the today's event will be Ronak will be starting off with his session, and post this we'll have a Q&A. and after that, like if we have any doubts and stuff, then we can go ahead with them. So over to you, Ronak. I guess you can start now.
Okay, thank you, Shubham. Hello, everyone. Thank you for joining today. So today we'll be talking about basic of Azure Kubernetes Service. But before we start, let me just give a, quick introduction about myself. So, hello, my name is Ronak Banka. I work as a senior solution architect with VMware in Singapore.
uh,
I've been
Ronak, I guess let me just add you back to the stream. You're not audible.
okay. Is it better now? Is it okay now, Shubham? Okay. Yeah, so I work as senior solution architect with
If there is
VMware
some
based.
issue, I'll just see.
Okay. Um, okay, I think. Okay, just a second, guys. Sorry for the.
Yeah, Ronak, can you try speaking again?
Yeah, is it okay now?
Okay, I
Okay,
guess.
okay, cool,
All
cool.
right, Ronak. Okay, okay.
Oh,
There
okay,
was some issue with my end. Okay,
okay.
Ronak.
Thank you, Shubham. Yeah, so I've been working with like Kubernetes cloud containers for a few years now. I've been helping companies, big organizations to follow SRE practices, help them mature their Kubernetes practice, application modernization, and in past time, I love cooking. So if you want to follow me on Twitter or you want to check my blog, I've pasted the link over there. Okay, so let's see what our agenda is for today's webinar. So we'll be going through few things. Right now, I'm assuming that I have mixed audience where people have zero knowledge of what is a container and people who have fair amount of knowledge of what is Kubernetes or how to use Kubernetes. But this is basically our agenda. It will look. We'll talk about okay, what is container. We'll go through things about what is Kubernetes, how Kubernetes works, and then finally we'll check, okay, what is Azure Kubernetes Service, how Azure can help us to simplify our journey for Kubernetes. And then the good part, which is the demo. So we'll be basically seeing that how we can get started with Azure Kubernetes Service. Okay. So first thing first, uh, WTF is this container. So everyone is talking about container these days. People are saying that containers can solve every problem we have. Container is this, container is that. But what is this container which people are talking about? So these are containers as well, but obviously these containers won't help us to solve our software problems or our application problem or our modernization problem. These containers are for something else. So let's see which containers are we talking about. So our definition of container. So a container is a standard unit of software that packages up code and all its dependencies so that application can run quickly and reliably from one computing environment to another. So this is definition by Docker website itself, but let's focus on two things. One is packages up code, and the second one is application runs quickly and reliably. So what we have seen is people have been struggling, organizations have been struggling to standardize their practice on how they want to ship the software, how they want to ship the code. And that's not the only problem. The other issue is how to run those applications quickly and reliably from across different environments. People have various environments across maybe public cloud or private cloud. So how they can ship the application, that's where container comes in. We'll look through what it looks like at a later stage, but yeah, let's go ahead. So before we talk about what container actually can do for us, or what are the benefits. Let's go back in time and see why containers were so useful and how things were done before and how they are now. So if we see that in before, like maybe 5 years or 7 years before, people were stuck on traditional deployment where they have physical boxes, hardware boxes, where they were installing operating system manually, they were deploying applications. Everything was like manual and it was very tiresome. Then came an era of virtualization where companies started modernizing their infrastructure. They introduced an additional layer, hypervisor. They virtualized their infrastructure. They virtualized their deployments. And then instead of working on physical machines, people started talking about virtual machines. So virtual machines helped us to install different operating systems in different virtual machines. And then on top of that, we were running applications. This was good, this was no issue, but then there was one thing where VMs take a lot of time to boot. So that was again a difficult part for organizations to manage. It was a big overhead. Then came the new era, which is the current era of container deployment, where companies said that, okay, we don't want to just virtualize our hardware, virtualize our infrastructure. We want to have a standardized container runtime which will basically run all our containers. Now, once you have your container runtime, this is basically our container where we say that, okay, we have all our software libraries and we have our application sitting inside that container. Difference between VM and a container is that container uses underlying Linux like basically Linux, you say CPU, memory, and all those things from underlying host, whereas VM has its own operating system and everything by itself. So why containers? So containers helps us to solve few issues. For example, isolation. We have seen that, okay, we have seen various companies having this issue where they were facing issues with, okay, I have noisy neighbor problem, or there is a security risk of having different production applications running at the same time on same machine. So containers helps us to get isolation using Linux namespaces and at network level, at kernel level, and then it helps us to scale our whole application suite. So for example, with VMs, it would take few minutes to do this, but because containers are so lightweight, they helped us to scale all our applications very quickly in few seconds. Uh, Once your container is created, we see it will help us to basically have a consistency across different environment. So containers helps us to have a consistent environment across different geographies or different places where we deploy. And then, yeah, once you have your container, when we say container, people usually think about Docker containers because Docker have made it so popular. But container can be any like any container which follows the specification, the container specification. And then once you have a container, you can run it anywhere, whether you want to run on your private cloud, whether you want to run on your public cloud. That's basically same across all your environments. Okay, so containers are really good, but that's not all. Like when we say that with great power come great responsibility, over here containers give us a lot of power. But what we have seen, what companies, organizations have seen is that when you start using container, you face a lot of challenges. And what are the challenges with container is that they are difficult to manage. They are difficult to scale when you're like maybe talking about thousands and like millions of containers. How to monitor those containers? How do I do networking between those containers? What is the proper way to manage configurations across my containers, across my whole application deployment? How to do service discovery if I'm talking about microservices? How to do load balancing if I'm talking about maybe different microservices running under same application path? I want to use, how can I do all those complex things with containers? So when people realized that okay, there are a lot of challenges with with containers, they thought that okay, probably let's see what all viable solutions we have in the community. And there were like few tools of container orchestration. For example, Azure Kubernetes Service, which we are talking about, Docker Swarm from Docker, GKE, Amazon ECS, EKS Kubernetes. We talk about Mesosphere, we talk about Cloud Foundry. So because there were a lot of tools in market out there, companies were having obviously difficult time that okay, which one to choose. But again, they don't have to like maybe think about all of them. But let's just talk about for now. Let's talk about Kubernetes because that's why we are here to learn more about what is Kubernetes, how does Kubernetes work. So, okay. So what is Kubernetes? This is basic definition from Kubernetes websites itself, kubernetes.io. I'll just read it. It's basically Kubernetes is a portable, extensible, open source platform for managing containerized workload and services that facilitates both declarative configuration and automation. There are a lot of complex terms in this definition, but if we try to focus on few things, for example, if we see it's an open source platform. It helps us to manage containerized workloads. It helps us to run services, and it facilitates both declarative configuration and automation. So when we say declarative configuration, it helps us to maintain our state of application. So let's take an example. When we deployed our application using all different VMs, there were a lot of issues with those applications. How should we scale them? If someone did something on one of the application instances and now it's like in a bad state, how to make sure that those things are in a consistent state of what we expected. So that's where Kubernetes comes in, where it says that, okay, we will follow this declarative configuration where you tell me that, okay, what I want to run. So for example, if I say I want to run three application instances of maybe some Python app or maybe some Nginx container, once I tell Kubernetes that, okay, this is what I want to run, it makes sure that it's in the consistent state. Even if you delete one of the instances, Kubernetes if is capable enough to basically restart those application instances for you in the last known state, which helps you to maintain the consistency across your whole application deployment. And then obviously, once we have all these declarative configurations, it's very easy for any application developer, or it's very easy for any organization to build automation around those. Because once we start, let's see what all things Kubernetes can help us with. So first one is service discovery and load balancing. When we talk about microservices, this is one of the biggest concern with developers, that how should my different microservices they will talk to each other. That's where service discovery comes in, which Kubernetes helps you in a really nice way. Also, it helps you to consume load balancing services from your cloud provider. So, for example, we'll be seeing in our demo that how Kubernetes is able to communicate with Azure to basically help us provision a load balancer, provide us a like path to access our application. Um, Second thing is storage orchestration. Storage managing Kubernetes is self-sufficient to manage the storage as well for our cloud provider. It allows us to do automated rollout and rollbacks. So we all have been this situation where we deployed an application in production and we have seen that okay, maybe there was a bug or it was not working as expected, and we have to roll out our application. In traditional world, that was a really big issue, because you have to like literally attach your VMs with the load balancer, do all the manual work, which was not very efficient. uh, Kubernetes allows you to roll out and roll back all those changes in a very neat fashion, where you just have to tell that, okay, all I want to do is roll back to a particular version, and then it basically manages everything for you. Network policy support. As an application developer, we have all seen the situation where we have to raise few requests, maybe workflows or tickets to get our stuff done. Whether it is firewall requests, whether it is network related things, Kubernetes helps us to automate some of those things by using APIs. Kubernetes supports things like network policy, where you can define your like complex network policies between different application instances, how they should talk, how they should like communicate to each other. Basically, you can define port and everything over here. Then we already discussed about the self-healing. So especially like people who are on the operations part or maybe support part for applications, like this is one of the biggest challenges where people have to maybe get up at 3 in the night or maybe like very early morning to fix something. Something broke, and then they have to literally get up in the middle of the night and start working on fixing things, maybe because one of the instances crashed off a VM or a couple of hosts crashed. Kubernetes helps us to manage all those things, like like I mentioned before. It helps us to self-heal our application instances, so we don't have to do all those things manually. Um, Secret and configuration management. Security people love it because if you are deploying anything traditionally or manually, there is always a chances of messing up secrets or exposing the secrets which no organization likes. So Kubernetes have really good integrations with secret management tools, whereas you can create your secrets, ask Kubernetes to manage for you, so you don't have to all those things manually. And then obviously, uh, we all been talking about this. Kubernetes is the next API for infrastructure because it can manage so many things. It can talk to your DNS services, it can talk to your load balancers, it can talk to your network tools, your storage engine. So it's basically a API for infrastructure where people will just use Kubernetes API to create all those underlying infrastructure which they have to create, or they don't even have to create infrastructure because once you define what you want, Kubernetes will itself go and create for them. And at the last, it can run your apps too. With all those fancy things, the best thing it do is it runs your apps, and that's all we want, to run our apps properly and in production. So this was basic introduction of what is Kubernetes and how it can help us. Now let's talk about how Kubernetes works. So we know that okay, it can do a lot of good things. It can help us to run applications, blah blah blah. But how does it work? So this is just like very small overview of the Kubernetes architecture. So let's see how it looks like. So over here we can see that there are few boxes here. We don't have to like understand each and everything because this is like still very basic overview. But over here we see that there are multiple components where one is a Kubernetes master, and then we have Kubernetes nodes. So in this case, like every proper distributed system or every platform, there needs to be a API server which is basically entry point for our communication with the platform. In this case, I'll say communication with the Kubernetes cluster. So if you see that person over on the left side, it is developer slash operator. There are a lot of things on Kubernetes, different API resources, which can be consumed either by, can be used by developer, or they can be used by operator, depending on what they want to do. Um, and then Kubernetes allows you to have very granular access. So in Kubernetes master, when we talk to anything using the APIs, is basically the API server. And then we have components like controller manager and scheduler, which are responsible. So for example, scheduler is responsible to manage all the scheduling for the pods and all. And then if we see there is a big HCD over there, HCD is responsible for storing all the data. Because we have an API, we need a place where we can store all the metadata, where we can store all the state of what is required for different applications. So HCD helps us to manage, helps Kubernetes to store all the data in there. And then if we see there, the two blue boxes, those are Kubernetes nodes. So Kubernetes nodes are the the place where all the magic happens. All our applications actually run inside the Kubernetes node. So if you see something, if you see those small blocks which are written as pod, those pods are the smallest entity which can host multiple container in itself. So those pods are responsible for running your applications and more complex things like sidecars and all. But yeah, that's probably maybe another discussion. So pods are responsible to run your application. And on top of that, if we see, there is a component known as kubelet. So kubelet is responsible for managing, you can say kubelet is the authority of that particular Kubernetes node. So whatever happens on a node, kubelet basically helps us to achieve that. So kubelet talks to API server, and then kubelet also helps us to manage all the pods which are running on that particular node. Then another thing, which is another component, which is kubeproxy. Now, we have deployed our application. If we are deploying our application, someone need to access those applications. How that is achieved? So over here, kubeproxy helps us to basically navigate that traffic, route that traffic across our different pods, so that our users can enjoy what our awesome developers have developed for them. And then if you see at the lower end, there is a long arrow, which is basically tells that it's the networking plugin. So there are a lot of different networking plugin out there which are compatible with Kubernetes. For example, Calico, Flannel, vwork, etc. Uh, you can choose your own plugin depending on how flexible is the cloud provider for that. Okay, so that was the basic overview how Kubernetes looks like. What is our basic components? Now, important thing for today, Azure Kubernetes Service. So let's talk about what is Azure Kubernetes Service and maybe how it can help us or what all things it can offer. Yeah. So features. So Azure Kubernetes Service is a fully managed Kubernetes cluster by Azure, by Microsoft, so that you don't have to manage your clusters by yourself. It's very it's not that easy to manage your Kubernetes cluster if you are doing maybe DIY, do it yourself type. So that's why Azure helps us to like manage like a cluster for you. It's easily scalable and it's secure by default because a lot of people work on the security for these infrastructure for these platforms. Um, you can run Linux containers, you can run Windows containers, and you can even run GPU workload over there. Windows containers were not a thing some time back, but now they are. So you can run your native .NET applications on Kubernetes as well. End-to-end developer experience, because AKS allows you to create, manage your cluster so easily with a lot of different integrations. We'll look in the next slide. It helps developers to create an end-to-end experience so that they don't have to like plug and play different tools. They can like have a whole experience over there. And then it's not very important part, but yeah, pricing is based on compute. So it completely depends on what type of Kubernetes node, worker nodes are we selecting to run our applications. And those are the VM sizes of worker nodes. They don't charge for master nodes. Okay, so that was our like basic what all features can Kubernetes offer us, AKS offers us, and then we have integrations with AKS. So Like I mentioned in the previous slide, Azure gives you a lot of tool which helps you to create a whole pipeline, a proper experience, end-to-end experience. Things like Azure Container Registry, where you can store your applications container images so that you can run them on AKS very easily. You can enable monitoring for your clusters so that you can see what is the health of your cluster. You can even enable like application insights, which is basically APM under Azure Monitor to monitor your applications, how well your applications are performing. Um, Azure DevOps for CI/CD. So if you want to maybe create a end-to-end production deployment pipeline, you can create that using Azure DevOps. Uh, that's very flexible. So you can you can do a lot of customization around release and other tooling in Azure DevOps. And I mean Azure. So let's look at the last point. As a developer, we don't have to like play with those things, but those are very good things as a user onboarding process where we can see that like when we integrate with Azure like AD, we can easily onboard our users to the platform. Okay, so let's see demo. Okay, before we go to demo, I'll probably maybe just go through few like do we have
Yeah.
okay some comments. Okay, I think they're kind of answered by. Okay, okay, then I think we can move forward.
Yeah, Ronald, I guess we're good to go.
Okay, cool. How much time we have, Shubham? Can you just update?
We have around 25 minutes, like 25
Oh,
minutes for good.
okay, okay, cool. Yeah, I
Okay.
think yeah, I'll probably I don't think I'll need 25 minutes, but yeah, I can probably spend some more time on answering questions. Cool.
Yeah, yeah, yeah. Yeah.
Okay, awesome. So let's look at our demo for today. So what we'll be doing is that we'll be creating, we'll see that, okay, how we can get started with AKS, how to basically create a cluster, how to deploy an application. So to make easy for our audience, what I've done is I have written a blog on what I'm trying to do today, so that I'll give the link to the blog so that after this webinar, if you want, you can just go ahead and try all those things by yourself. Okay, so just give me a second. Let me share my screen. I'll probably share a different tab. Okay, cool. Okay, so okay, so what we are doing is I'll just give a brief overview of what this is. This is actually the Azure portal where we have all our different services. So you can have all different services, whether you want DB, whether you want virtual machines, whether you want load balancers, whether you want Kubernetes service. So all these things are, all these services are here on our AKS cluster. Now, what I've done is when you sign up for a subscription on Azure, actually when you sign, just for information, when you sign up on Azure, they give you good enough credits, I think $200 worth credits, so that you can try their different services. So I've also mentioned that in the blog. But yeah, to getting started, what I've done is I'll be using something known as Cloud Shell. So if you see this small icon over here, what you does is that when you click this Cloud Shell, it basically creates a Cloud Shell like this, where I can execute all my commands. So I've already created a Cloud Shell, but if you are when you start for the first time, it will ask you to like create a storage and all. So don't worry, everything is in the tutorial, so you can like go through that tutorial later. So what we'll be doing is that the reason why I'm using Cloud Shell is that you don't have to install anything. Like all the things which you need, like few important CLIs, they are already there. So for example, okay, I think I can probably enlarge this. Okay, just give me a second. Yeah. Okay, so we'll be using Azure CLI, which is known as AZ. It is by default installed on this Cloud Shell. So I don't even have to install those CLIs over here. It has a lot of commands, but what we'll be using today are basically two. So we'll be using commands for subcommands for Azure Kubernetes Service. But before we do anything on the Azure Kubernetes service, I'll probably just show you what we are like. There are some resources which we are trying to create. Okay, just give me a second. I'll probably share a different tab. Okay, cool. So if you can see my screen, like I mentioned, when you try to launch your Azure shell for the first time, it will ask you to do few things so that you can getting started with the shell. And then once you do AZ account show, like once you create a subscription, open the Cloud Shell, it will give you a nice JSON like this, telling you what all things you have over here. But next thing, what we'll be doing is that we'll be creating a resource group for your Azure Kubernetes cluster. Now, what is a resource group? So a resource group is something in Azure where all your entities which you want to create, all the services which you want to create, they reside under the same umbrella. So you can say that basically if you are starting a new project, you can create a new resource group, and then you can create all the different things which you want inside those resource group. So to create, before we start creating the resource group, this is something which we have to do, which is basically, I think I'll complete, just give me a second. Yeah. So we have to list a few things that, okay, what is my location? So for example, I'm based in Singapore. So I used Southeast Asia, if you see over here, but you can basically choose your own location based on where you are working. So yeah, this thing is very bad. I can't. Yeah, there is some issue with my sharing, so I have to like switch tab again. Sorry for that, guys. Yeah. Okay. So let me run this thing. So once I run this command on my Azure Cloud Shell, it basically gives me this nice list over here, which tells me that, okay, what all regions are present where like I can create my resource, where I can create my resource group. So for example, over here, I have used Southeast Asia. Yeah, so I have used Southeast Asia, but then sure, you can use your own region. You can use US West, you can use South India, you can use any region you want. But just FYI, there are few regions, for example, South India. Um, you have to probably change the VM type. Probably I can check that later. But yeah, let's move with Southeast Asia because we have to like getting started over here. So over here, what I've done is I have so let's first check what we'll be doing to. Okay, I think I should probably enlarge my screen. Yeah, okay, this is much better. Yeah. So what I'll do is I'll basically create a new group where I say that, okay, AZ group create. I'll create a new group by name Skillenza, and then I'll create this in Southeast Asia location. So once I run this create group command, what it will do is that it will basically uh, create a resource group for me. So if we see here, it basically says that, okay, it is a type of resource group. So once I've created the group, now I can start creating my Kubernetes cluster. So let's see what we have to do to basically create our cluster. So if you all see this command, what we need is all this simple CLI one-liner to create our Kubernetes cluster on AKS. So what we do is we say that, okay, Azure AKS create a, a Scalenza hyphen like AKS cluster for me in resource group Scalenza. And to make it more faster, what I do is I'll create a node count as one. So it will just create a worker node, just one worker node instead of having multiple worker nodes. And then I can specify that which Kubernetes version I want to run. We can list all the Kubernetes version we want to run. Just look at set AKS the command. But yeah. So just give me a second. Yeah. So for example, if we do Azure AKS, and then if I do, oops, yeah, I can do get versions. So it will, okay, location Southeast Asia. So once I give this one, it will actually give me a JSON, but I like in table format more. So I do AZ AKS get versions, and then I'll say that, okay, use a location Southeast Asia. So it will give me what all Kubernetes versions are available for me on the in this region. So I want to use 1.17.5. So I've used that in my script to basically create that cluster. So now what I'll do is I'll create this cluster um, over here. So let's see. So if I, uh, damn, okay, just give me a second. Okay, just restart this. Yeah, looks like my credentials got expired. Just give me a second, guys. Okay, while I'm restarting this one, yeah, this will take a shouldn't take much time. Okay, so let's go to our scripts. I'll try to run this again. If demo gods are with me, this should work fine. If it doesn't work fine, I have a backup plan to show how to deploy application. Yeah, looks like it doesn't help me. Okay, no problem. So what I've done is I've already created a cluster. I mean, this is what is expected. I still have to debug whether it is issue. But for example, if I just do create cluster, AZAKS create, it will basically create the cluster for you. So just to be on the safe side, I have created a cluster before this. So if I list my table, I can see that, okay, there is a cluster over here where the name is Arbunka AKS. That's my name. And on top portion, if you see that in Kubernetes services, I can see my this particular cluster over here. So I can see my overview that, okay, what is the location, what is the subscription ID, what is the Kubernetes version, what is the API server address. All those things are present here. So just give a second. Yeah. So let's get back on the stuff. So if I have to basically list my all the clusters, what I'll do is I have a command for that. So I can list my clusters, but what I'll do is, so let me list the clusters which I just shown now. So I can list my clusters over here. I can see the provision state is it's already provisioned. Now, once our Kubernetes cluster is done, what can we do to basically get our credentials? So once our cluster is up, we have our API and everything running. Now to getting started with the application deployment, we have to get the credentials for our clusters. So for that, Azure gives us a very nice CLI where it says that, okay, is it you say AZAKS get credentials, which resource group and which cluster name. So the moment I run this script, which is basically the same command, what it does is that it gets the kube config. So those who don't know what is a kube config, uh, when you run a Kubernetes cluster, uh, okay, I think I can see a few fonts thing. So I think this must be much better. Yeah. So those who don't know kube config, uh, when you deploy a Kubernetes cluster, to talk to your Kubernetes cluster, you need something known as kubeconfig, which is you consume using kubectl. So over here, if we look at, so if I do kubectl, this is basically the CLI which is already downloaded, already installed in my Cloud shell, so I don't have to do anything. Now, when my kubeconfigs is applied to this particular file, let's check what is status of our cluster. So if I do kubectl get nodes, I can see that it should list my worker nodes. See, so over here I can see my worker nodes, and role is status is ready and role is agent. Now, if I do kubectl get pods, so when we do kubectl get pods, it lists us all the pods which are running in the default namespace, so that in the next step, when we'll be deploying the application, we'll be able to see the pods running over here. Um, Now let's go and deploy our first application. So so there is like a sample application on Azure GitHub account itself. It's in the it's in the tutorial blog, but I'll just show you here what it looks like. So it's basically github.com, Azure samples, and then Azure voting app. So this is like very sample app, which is actually based on Python. So I thought probably we are working on Python on Azure. So I'll probably choose a Python app. So this is a Python app which uses Redis as a backend. So if I just maybe show you the how this looks like, this is how a Kubernetes deployment have to look like. You don't have to remember this. You can just copy it and run this. But over here is just like definition that, okay, what is a deployment type? What is my labels and like other things? What is my container image? So for example, here it is Redis. If I go down, this is the front end app, which is a Python app, and then I say that, okay, which image? So just use my Microsoft Azure VoteFront version 1. So this is the basic definition of like what our Kubernetes deployment will look like, app deployment will look like. To actually run this particular app, all we have to do is we have to do kubectl apply, and then we have to tell Azure vote all in one Redis. So when we do this, what we are expecting is that it should basically run few things for us. So see, the output is it created two deployments. One is Azure Vote Back, and the second one is Azure Vote Front. It also created two services. So what is a service? Service is something you can say maybe an endpoint which helps us to expose our application. So we have deployed our application, but now when we have to access those application from internet, we have to create those services. Now, if I do kubectl get pods again, I can see there are two pods here which are in status container creating. Um, because these are, it will probably like initially it will take time because it is still downloading all the images and all. So we'll probably wait for maybe a few seconds for this to run. So once our container are ready, what we can see is that all our like these pods will basically run in this particular namespace, and then with our services we'll be able to like access our application. So see, now from container creating phase it has moved to the running phase. So now what I can do is if I do kubectl get pods, I can see my these two pods. I'll just probably run again to maybe in a much better place. Also, I'll do kubectl get svc, which is actually to see that what is our, like, what all services are here. So if you look here, we have two services which are created. So one is our Azure Vote Back, which is our Redis service, and then we have Azure Vote Front, which is our like front application, our web application. Now, if you see, we have an external IP which is attached over here. So initially, when I mentioned Kubernetes is self-sufficient to talk to Azure and get you the load balancer and API, I was talking about this thing. So if you can, like, I'll just probably maybe copy paste this IP in our chat box so that everyone can access it, or if probably someone can add that to the private or to the public chat. Shubham, can you do that for me? I've
Yeah,
pasted, yeah. Can you just paste that link on the public live comment so that everyone can open the app while I'll open the app here.
sure, sure, Ronak. I'll just do it.
Okay, so let me stop my sharing. I'll
No,
share a
no.
new,
Okay, okay. You wanna share something? Cool.
yeah, so okay, let me share my new screen. Just give me a second. Yeah, so this is how the app looks like. So I think already a lot of people have voted. So if I just add maybe one vote for cat, maybe one more vote for cat, I can see all these votes over here. Now, if I just probably maybe refresh, I can see that, okay, there are more votes here. I mean, dogs are winning for sure. So if you click on reset, then obviously someone clicked on reset, so all the votes are gone. So this is our public IP using which we are accessing our application. So if I just maybe refresh one more time, I can see someone again resets. I can just vote one for cat, couple of more for cats. So yeah, I think this is our, like, we can access our application from our Kubernetes cluster. So this was the test application which I created. So let me go back to my presentation tab. Okay, so that was our demo where basically we deployed a sample application on AKS. We created a cluster we were not able to create actually, so probably some issue. So I already created one before, but yeah, it should work for you. Okay, so this is a link for the tutorial. I mean, we'll be sharing the slides so you can get from there as well. But if you want, you can scan that QR code and it will take you directly to the block over there. So I'll probably maybe stay here for a few seconds if anyone is scanning, or if not, then I'll probably paste this link and I'll
Yeah,
give Shubham in the chat so he can maybe put in the live comments.
sure, Ronak.
Okay, no problem. We'll be sharing the slides, so don't worry, everyone. That's okay.
Okay, I've shared it. Facebook has some issue with the devstack.in content.
Ah, okay. Yeah, I think I know that. We'll be sharing the slides, right?
Yeah, we will share the slides. No issues
Oh,
about
okay,
that.
cool. Yeah, but yeah, you can just scan the thing. It's okay. Okay, that was the link for tutorial, and thank you everyone for joining the webinar. You can find me at the rate Ronak Bunk on Twitter, or you can check my blog, https devstack.in. Yeah, I think that's all from my side. Thank you everyone. Back to you, Shubham.
Okay, so thank you so much, Ronak, for an amazing session. And I'm very sure our viewers out there, they would have found it already informative as well. So we have a couple of questions. I'll just look into this
Sure, sure.
and I'll just send it to you and maybe you can answer them.
Yeah, I'm sorry for that. The cluster was not created because of some issue, but yeah,
No
that's
issues. I
okay.
mean, yeah, it really has some region issues sometimes. Even I face it a lot of time. So
Yeah, it's yeah,
can you see this question,
yeah,
Ronak?
yeah. I can see. So, does it check for the downtime in real time and purge the instances in web app firewall? Okay, so Pratik, the way Kubernetes manages that, you can define something known as like your pod availability. So when you define the disruption budget and when you define your rolling upgrade, like when you assign your strategy, what Kubernetes does is that it by default, the depending on how much disruption you have provided, it actually kills one of your instances and then upgrade, like then starts with the upgraded version, and it does that the rolling upgrade for all your deployments. So you actually don't have downtime. That's a very nice thing about Kubernetes. uh, because of the rolling upgrades, there is no downtime for your end users.
Okay, so let me see. We have one more question from Preeti Sharma, but then Yogi has already answered it. Do you want to take it up, Ronak?
So I got stuck on creating the resource group. Can Anvil tell me what's the command for it? Okay, so Preeti, I think Yogi already put the command. So the AZ account. Okay, let me share my screen again. Just give me a second. Let me share my screen for the blog. Okay. So for the AZ account show will actually just show you your current account. So once you have created your Azure subscription and you go to Cloud Shell, AZ account show is just a command to show you that okay, what is your command, access ID and all those things. But to create the resource group, what you have to do is you have to use something like AZ group create. There is no a case in between. It's AZ group create hyphen hyphen name of your choice, and then the location of your choice. So once you give this location, it will basically create the resource group for you. Okay, I think.
Uh, Parmeet Singh has also one question. Which one is
Mhm.
better, taints and tolerations or node affinity?
Okay, so there are which one is better, taints and tolerations or node affinity, use case of both of them. Okay, so basically the use case is different. So let's talk about taints and toleration. So you have maybe different nodes where you have applied maybe different tags, different labels actually. So in Kubernetes, you can basically distribute all your nodes, or I mean, all your application instances based on those labels. So when you say that, okay, I've defined maybe label A and label B on like node A and node B, when you define taints and toleration, if you have a taint, maybe you define a taint on one of the nodes. If like you have a toleration on your app, basically your deployment, then only the deployment who have the toleration will be able to go to that particular node. Whereas node affinity is a different thing. Um, in case of node affinity, when you want to deploy an app and you want your app to just go on one node, you don't want any toleration or any taint, you can even just define the node affinity selector over there so that your application will only be deployed on that particular node. But again, it's more risky because if you are maybe deploying multiple if you only have, for example, one instance and that goes to maybe node 1 and you are upgrading node 1, because there is a selector attached, so that will create a downtime for you. Okay. So Nick wrote, okay, for my LinkedIn IT.
Yes, sure. No.
Okay, let me just share. I think Shom, you can share you
Yeah,
have.
I
Uh,
just-
okay, I'll also put that in the chat if you want. It's
no,
okay.
no issues, Ronak. Okay.
Yeah, so that's my okay. Yeah. So Preeti has comment, does app sometimes contain fault tolerance? If yes, how to remove? Preeti, I'm not sure what you mentioned. Okay, so if by fault tolerance you mentioned maybe like you want to do a health check for the application, then you can define the health check on a particular app. So if that health check is not passed, then your app won't start basically. So it helps you to ensure that before your service can serve any traffic to the app instance, is basically ready to serve those app instances. But if you're talking about maybe fault at code level, then what will happen if something breaks at the code level? It will probably try to restart, it will lead to restarting of the container, which Kubernetes will try for some time before like giving it up, saying that okay, I can't do it anymore. But yeah, for yeah, you can define health checks for your applications. Okay. Do we have any other question, Shubham?
No, I guess we're good, Ronak.
Awesome. Thank you,
So,
everyone. Yeah, yeah,
thank
Shubham,
you.
go ahead.
Okay.
Okay. Yeah, I think we can wrap up. Thank you and everyone for joining. It was really nice to like give this webinar. Yeah.
Okay. I guess my screen is visible, right? So,
Yeah. Yeah.
everyone, guys, please tweet about like what do you like, what did you like about the meetup, and you can obviously tag Ronak and tag Skillenza and tag Microsoft too, and how was your experience. So here's a link, which will help you. So maybe you can just note this down. You can read more about like how to build some amazing things on Python on Azure. So thanks a lot everyone for joining. And since like I mentioned, this is a series of webinar. So we will have the next webinar on 11th of June, which would be on Azure durable functions. Also, just to our viewers, we'll be having a quiz which would be on AKS on our Skillenza platform, which will go live on Tuesday. So you can take up this quiz, and people with 60% of score will be awarded with a certificate from Skillenza. All right, and thanks a lot, Ronak, again for joining us.
Thank you, Shubham, for having me. Thank
Okay,
you.
all right then.
Okay. Thank you, guys. Good night. Have a nice weekend.